In this lesson, we're going to continue from where we left off yesterday with ratios. Today we're going to do a few more of the word problems and just get some more practice with understanding the idea of ratios being equivalent. In other words, means different version of the same ratio. So we're going to start off with some straightforward ones where we just have a problem, we want to solve it. Okay, I've got two ratios. They're written in a good form for us, as in their fractions. And I know that the ratio 3 to 5, that's really what that means, 3 to 5, is equivalent to something over 15. I need to find the factor that makes them equivalent. Do I have to multiply? Do I have to divide? How can I convert 3/5 to something over 15? The easiest way of looking at this one is, well, I know how to turn a 5 into a 15. I multiply by 3. Now if I multiply the bottom by 3, I have to do the same thing to the top. A reminder from yesterday, we use the arrows. They're pointing in the same direction to the same operation, and x, 3 times 3, makes 9. If we take a look at the second one, 65 over 40 is the same as 13 over something. And this one's a little bit trickier because I can't, off the top of my head, think of how to turn a 65 into a 13. I know it's getting smaller, which means I'm dividing. Well, what am I dividing by? If you're not sure, type in your calculator. What is 65 divided by 13? Turns out it's 5. So I've got to turn a 40 into something. I'm pointing the same direction, so I'm going to do the same operation. Let's divide by 5. And x is 8. And I try the last one. I want to turn 3 over something into 18 over 24. I need to turn a 3 into an 18. In mental math, I can times this one by 6. That'll work. If I want to figure out the x, however, I got to turn the 24 back into the x. Notice that my arrows are pointing opposite directions. So I'm going to do opposite operation. I'm going to divide by 6. Here, x is 4. Now let's say in that one you couldn't figure out 3 times 6 makes 18. What could you have done? Well, we could have done 18 divided by 3. It turns out that's 6, which means 24 divided by 6 is 4. Same answer, just it's the opposite operation. So if you can use your mental math skills and figure out the multiplier, great. If not, use the dividing trick. It works the same way. Okay, now these are just some warm-ups, but the idea in all of these is that if I can take a ratio that I know, 65 over 40, and part of a ratio I want to know, I can solve them as long as I know that they're equivalent, different versions of the same thing. That's kind of our big idea when it comes to word problems. We want to set up a ratio that we know to solve one that we want. Just got to interpret the questions. Let's look at some examples here. When a robin flies, it beats its wings about 23 times in 10 seconds. That's a ratio. 23 times in 10 seconds. Now I'm going to put the word times here, and I'm going to put the word seconds here, so I know which one's which. I want to know how many times will it beat its wings in 2 minutes. Okay, so here's my unknown ratio. Now, something interesting about this one. How many times will it beat its wings in 2 minutes? I don't know how many times. Times are on the top. That's what we said over here, right? So I got to make them the same ratio. That's the thing I don't know. The thing I do know is I want to know how long it takes in 2 minutes. Now some of us might want to put the word or number 2 in here. But if we stop and think for a second, we got ourselves a little problem here. One of these is seconds, one of these is minutes. That's going to be hard to make a ratio. Those aren't equivalent. They're different ways of measuring time. So we've got to fix this before we start. I got to stop and think about what do I know about 2 minutes in terms of seconds. Well, I know 1 minute is 60 seconds. So 2 minutes times it by 2 is 120 seconds. I've got to make sure when I'm setting up a ratio that I'm actually setting up equivalent things, 120 seconds. Okay, seconds with seconds, times with times. Okay, they're the same kinds of things. Now I can go about solving this problem. I need to turn 10 into 120 or 120 into 10. Well, 120 divided by 10, make it smaller, is 12. 23 into the other number, the bigger number, and I do the opposite arrows. That's a big one. 23 times 12, I need my calculator for that one. I get 276. And because this is a word problem, we're going to give a word answer. Bird will beat its wings 276 times in 2 minutes. Okay, let's try some more. The gear ratio. When you have gears, you have to turn something. The two gears, how they meet together, have a ratio. Right? The gear ratio between two connected gears is 3 to 2. Hey, I know that right now. It's a ratio that I know. Let's write that down. Okay. The larger gear has 126 teeth. How many teeth does the smaller gear have? Well, in the ratio that I know, the 3 has to be the larger gear, and 2 has to be the smaller gear, because 3 is larger than 2, right? How many teeth does the smaller one have? That's the thing I don't know. That's my small one. And I do know that there's 126 teeth in the large one. Well, this is the ratio. I want to solve it. Okay, so we got to turn a 3 into a 126. That's tricky multiplying. So let's do our dividing trick. Let's divide by. 126 divided by 3 is 42. I got to turn a 2 back into the bigger version, so I'm going to times by 42. Opposite direction, opposite arrows. So x is 84. Therefore, there are 84 teeth on the small gear. Okay, let's try part B of this question. Suppose the smaller gear has 126 teeth. How many teeth does the larger gear have? Let's give it a try. What's the ratio we know? 3 to 2, large and small. What do we want to find out? 126 teeth on the small one, and I don't know how many on the large one. So same numbers, right? Just in a different pattern here. Turn 126 into a 2, I'm going to have to divide by 63. So I'm going to have to multiply by 63, opposite direction, opposite operations. And 3 times 163, sorry, 3 times 63 is 189. There are 189 teeth on the large gear. Okay, so we're going to be doing the same kinds of questions over and over again. If we can follow the same procedure, it makes it a little bit easier. A fraction that we know, a ratio that we know, and part of one that we don't know. Okay, so I'm going to let you give this one a try. Pause the video, try it, see if you can figure it out. If you tried it, come back and watch. The ratio of girls to boys at Mount Forest Secondary is 5 to 4. 5 to 4. And the order is girls to boys. So girls and boys. If there are 360 boys, how many more girls go to Mount Forest? So boys is 360, and I don't know how many girls. That's the thing I'm unsure about. So I'm going to turn a 4 into a 360, or a 360 into a 4. So let's divide it. That's big numbers. Okay, so I'm going to the left, I'm dividing. Going to the right, I'm going to have to multiply. And I think x is 450 girls. Okay, let's do our therefore. There are 450 girls, right? But that actually wasn't the question. If you go back and look, it says, how many more girls? Well, there's definitely more girls than boys. There's 450 girls. There's only 360 boys. The question is, how many more? Well, let's figure out the difference between those. The difference between 90 more girls than boys. That's what the question is actually asking us. There are 90 more girls than boys. We got to make sure we read the question to make sure we've answered what's being asked, right? Not just finding something about the question, find the right answer for the question. Okay, try the next one again. Pause it, give it a try, see if you can get it. In an election for student council president, 480 students vote. Erica receives 55% of the votes. How many votes did Erica receive? They didn't give us a ratio. Not exactly. They gave us a ratio in a tricky version. This is my ratio. What do we know about percent? Percent is out of 100. So if Erica receives 55% of the vote, she's getting 55 out of 100. That's the ratio that we know. Whenever we deal with percent, it's always out of 100. We can always rate it as a fraction out of 100. So here's how much she gets. This is Erica out of the total, 100%. Okay. What do we know? We know that 480 students voted. That's the total, right? What we don't know is how many votes Erica got. Well, there's our ratio again. This one, I had to think a little bit because it's percentages. I know percent always out of 100. Okay, I'm going to turn a 480 into 100. I'm going to have to divide by 4.8. Ooh, decimals. Which means I'm going to have to multiply by 4.8. All right, if I try that in my calculator for this one, I got 264. Erica receives 264 votes. Okay, so I'm always going to give you a ratio that you know. Sometimes I might do it in a slightly tricky way where it's a percentage, but we still know the ratio. Kind of a key to solve one. Okay, I got two more, and then we'll finish this lesson. Anyway, we can give this one a try also. A school holds a lunchtime fundraiser, and 1/3 of the students of the school participate. If there are 720 students of the school, how many participate in the fundraiser? So where's the ratio that we know? I have a lunchtime fundraiser, and 1/3. 1/3. What do I know about the number 1/3? That's 1 out of 3. Hey, that's a ratio, right? It's a different way of giving us that ratio again. How many people participated? This is 1 out of every 3. That's my total. Kind of like the percentage way, but giving it to a different form. If there are 720 students at the school, that would be the total. How many participate? That's what I don't know, my participation. Well, there's my ratio. I got to turn a 3 into a 720. Ooh, big numbers. Let's go the other way. Let's divide by 240. Which means I have to multiply by 240, which is a nice one in this case, because 1 times 240 is 240. Did I answer the question? What was the question? How many participate? Well, that's what I figured out. 240 students participate in the fundraiser. Okay, there's no trick to that one at the end. The trick was giving us the ratio, and that 1/3 is actually the fraction we need to work with. Okay, last one. Pause it, try it. Sam and Joe collected stamps in the ratio of 6 to 5. Well, that's an obvious one. 6 to 5. Sam is the top, Joe is the bottom. If Sam collects 36 stamps, how many stamps do they collect altogether? So I know Sam got 36. I don't know how many Joe got. Okay, I can solve this. I can divide this way, divide by 6. So to multiply by 6, x is 30. Okay, so what do I know? I know Joe collected 30 stamps. Was that the question? How many stamps Joe collected? No, it's how many they collected all together. So I gotta take Sam, that's 36, and Joe, who had 30, put them together, and all together we got 66. Together, Sam and Joe collected 66 stamps. Okay, so I gotta make sure at the end I've answered the question that's being asked. Okay, sometimes one little extra step, I had to add something or I had to subtract something. Okay, all based on the ratio that we know when we want to solve. Okay, that's the end of the lesson. Try the homework sheet that's attached. If you're stuck on it, come see me. Okay, that's kind of the end of ratio stuff, so we're going to move into more about percents and rates tomorrow, just special versions of these things.